computer. Alright, hello ladies and gentlemen. Now we will talk about Lab 8, which is about statistical tests. Just a short introduction to how this statistical test stuff works. Now we have statistical tests. There are two types of statistical tests. Somebody's asking out of curiosity, the last lab was essentially the hardest one. Yes, I would say the last lab was the hardest one. That's why it took so much time. So there's two types of statistical tests. Parametric tests and non-parametric. And of parametric, there's two types of tests. The z-test and the t-test. Non-parametric, thank God, there is only one type you have to deal with, which is the chi-square test. So the z-test is used when the standard deviation is given. So standard deviation, let's just see, when the standard deviation is given, we do the z-test. When the standard deviation is not known, we do the t-test. Parametric tests are only for normal distribution. Non-parametric tests are universal. So whoever is asking, still confused as to what STD is. It's standard deviation. It's one of the values. So, you could have mean, you have median, you have variance, you have standard deviation. By the way, don't worry, you will see the first question that we solve, you will instantly know. By the way, this is another question, variance and standard deviation. What is the relationship? Standard deviation is basically the square root of variance. So if they give a variance and they ask you to know the standard deviation, you just take a square root of variance. Okay, so you will know what it is soon enough. So this is for universal. Okay, so the z-test and the t-test. What formulas? So right now we are going to deal with the z-test and the t-test, the parametric tests. Now parametric tests have the functions z-test. You have a very simple function called z-test. T-test has a very simple function called t-test in MATLAB. Let me just see what other values, what other stuff is relevant. Okay, so for both the z-test and the t-test, what parameters, well, no, what results do we get? But before that, let us move to a question. So what is the purpose of the z-test and t-test? They are called parametric tests, which means, if you want to remember, parametric test means they take parameters. Parameters such as, this is a question, right? They take the mean, they take the confidence interval, which is the alpha. They take the alpha, they take the standard deviation, stuff like that. So this is the question. The volumes, in milliliters of soft drinks of a random sample of 10 bottles from a large batch were as follows. So the reason we use a z-test and t-test is to show that the values match a mean that is given. So these are the values of soft drinks. We are trying to prove that the average volume of the soft drinks is 500 ml. But since this is a factory and things can go wrong, some of them, these are the actual values, which is 499, 525, 498, 503, 501, and so on. So here this is something called null and alternative hypothesis. Now this is very important and it will probably come in the oral exam as well. What is the null and the alternative hypothesis? So there's something, null hypothesis is your primary assumption, and alternative hypothesis is the alternative things that can happen. For example, there is six, right? So there is a big six on the ground, and there's a guy here that's looking at it. And his null hypothesis is like he's saying that most likely this six is like this is a six. Null. His null hypothesis is that this number is a six. What are the alternative hypotheses? That it is not, there's three alternative hypotheses basically, but it's not a six on the ground. It's just a six, like straight up a six. So what are the alternative hypotheses? It is either not a six, like the actual number is not a six, or it is bigger than six, or it is smaller than six. These are the alternative hypotheses. So in this case, the null hypothesis, which is our primary assumption, is that the average volume is 500 milliliters. So that is another alternative hypothesis. Okay, what one more thing is given, the 95% confidence interval. So one thing that is used a lot in the data and the test is alpha. So the value of is alpha is also written like this, and standard deviation is written as sigma. So sigma is not that kind of sigma. Sigma is a Greek value that's written like this. So sigma is called, by the way, if you use help, if you use the help command, it will call alpha alpha and standard deviation sigma. It will just say sigma is given. It won't tell you standard deviation. So you have to know that sigma is standard deviation and alpha is just alpha. Yeah. So this is something you have to remember with these tests. Sigma, standard deviation, alpha is just alpha. But yeah. So what is alpha? Alpha is 1 minus confidence interval. So confidence interval is given as 95%. So 95%, you already know 95% in math. Math doesn't deal with percentages. Math is going to be 0.95. What is 1 minus 0.95? 0.05, which is alpha. So in this case, alpha is 0.05. By the way, you'll understand everything as we solve it. All right, so we have the mean, 95% confidence interval, standard deviation, and we can see the result here. Actually, no, this result is messed up. I'm just gonna solve it myself. With this MATLAB here. Hmm. The slides aren't too small, are they? Yeah. Okay, so we have our stuff here, everything that we need. Yeah. So what do we start with? We put all of this data into an array, data, and this is 499, 525, 498, 503, 501, 497, 493, 496, 500, and 495. Just to confirm, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is the data. What else is given? The mean. You can just write the mean here. What is the mean? 500. Okay. Confidence interval. So in this case, in the z-test and the t-test, we we don't need the confidence interval. We need the alpha. So we'll just find the alpha here, which is 1 minus 0.95, because I suck at math. I just do this. If you're good, you can just figure out that it's 0.05. What else is given? The STD, the standard deviation, is given of 3. So 3. So the person who asked me, like, he still doesn't know what standard deviation is. Standard deviation is just, something that you use if you're looking for the definition of standard deviation. It is just the square root of variance. What is variance? Variance is how spread apart the data points are from the mean. Basically, how much it varies. All right, so we proceed with the z-test. So we have these values. Now we do the actual z-test. We use the z-test function. And what does it take as the parameters? The first thing it will take, by the way, in the exam, STD is sigma, yeah. In the exam, you might forget what parameters to use in the z-test, in which case you do help z-test. No parentheses, you just run it. It will tell you, okay, what is in a z-test. Z-test expects x, m, and sigma. So, but it's not just that. You can see here other values as well. Here, x, m, sigma, these are the basic values. Parameter 1, value 1, parameter 2, value 2. We will be giving it two parameters, so that's irrelevant. So what does it say? X, m, and sigma. You can just, for demonstration purposes, I'll write it x, m, sigma, and then the parameters. Okay, now we run the z-test. Z-test. First thing, x is the data. What is m? M stands for mean. Mean. You can even write it manually in the exam. But since, I'm doing it to explain, I've stored everything before. So the data, the mean, the sigma is the standard deviation, and then the parameters. The first parameter that we will be giving is the alpha, and then the value of the alpha is stored in that variable. You could also just straight up write 0.05, and then we will be giving it tails. Well, tail. Yeah. Okay. Now to explain the concept of tail. So in this case, we actually have this thing here. I don't know how I can go now. This graph here. And let's see. This sucks. I'm just gonna go and explain it in Microsoft Paint. So suppose you have some data here. Just goes like, something. Now, in our case, in this soft drink question, It says that our null hypothesis is that it's exactly 500, which means that there is the alternative hypothesis. Well, basically for this data, the tail will be both. These are the two tails, the front tail and the back tail. Or, well, in MATLAB, this is called the left tail and this is called the right tail. And this is the data in question, which is 500. So, since it says that we we consider the ML to be equal to 500, it means both left and right are of interest to us. If it's more than 500, uh, if it's more than 500 or if it's less than 500, both sides are of interest to us. So we will include both the left and the right tails. If it is only less than, then we will do only left tail. If it is only more than, then we will do the right tail. So right now it's both. So that is the z-test. Let us look at the answer of the z-test. It is 0. Why is that? Because we didn't take the parameters the proper way. So what results do we get from the z-test? Because it's a function that returns a lot of useful stuff. So we will write them in square brackets. The first thing that we get is h, then p, then ci, and z. So let's look at the values. Okay, what is h? If h is 0, it means our hypothesis was accepted. You can just see here. Well, if h is 0, it means our null hypothesis was accepted. If h is 1, it means our alternative hypothesis was accepted. So since it is 0, it means that you know, the mean is, well, our null hypothesis, what is it? The average amount of cola or a soft drink in the bottles is 500 ml. So if it's 0, it means it was accepted. P is the probability of the test. I don't think it's asked for, but I'll just confirm later. Ci is the confidence intervals, which means that in this alpha, what is the confidence interval that we are taking? 95%. If we increase it, I think it will shorten this. So suppose we want 98% confidence interval. See, it changes the interval. Not by that much, but it does change it. So Ci will be the confidence intervals. And Z is the output of the z-test. This is important. This is basically the output of the z-test. Now, these are the values you get from the z-test function. One more thing is used in the questions, which is the critical value in all three z-test, t-test, and chi-square. So the critical value, you can get critical value is equal to. So for this, since the z-test is for normal distribution, you use norm I and V, normal inverse. So norm I and V, and what are the values? Now the value will depend on the tails, the alpha value that you give. If the tails are both, then you give alpha divided by 2, and the second value is 1 minus alpha divided by 2. Yeah, this is if both tails. What if left tail? So the way I remember this is that there is always a 1 on the right, because the right is the good side, like there's left and right. Right is the positive side, so there is always a 1. Just imagine this. There's two sides. There's always a 1 on the right side. Imagine it like that. So if there is a left tail, then the value you pass into it is alpha and 1, because there's always a 1 on the right side. What if it's a right tail? If it's right, then you need to put the alpha on the right. But there is already a 1 there. So if you follow the rules of algebra, if alpha is going from one side to the other, the sign will change. So this will become 1 minus alpha, right? And alpha was here, and now it's not here anymore. So it will just be an empty space is 0. So that's how I remember it. The professor told me it's the exact same thing. So alpha divided by 2, 1 minus alpha divided by 2, or just saying 1 minus alpha divided by 2. So since I remember it like this, and I find it easier to remember it like this, I'm just explaining it like this. And left tail and right tail also have two values. That's why I'm explaining with two. Okay, so for the left tail, the norm, like the critical values will be like this. So alpha and just 1 here. And for the right tail, the critical values will be 0 here and 1 minus alpha. The only reason you're dividing by 2 here for both tails is because they're two tails. So yeah, this is something you'll have to remember. Anyway, in our case, I'm just going to comment out this whole thing. Will not comment out the later because it's in the notes. So norm inverse, these are the critical values. And with that, we can actually go and solve. I'm going to say the last three lines, critical left tail and right tail, we use them based on what? If they see here, when I explain tail, if we have only right tail here, then we use in the critical value, when finding the critical value, we use here instead of alpha, this, we pass in that value. If it's left, we pass in the alphas for left tail. You would have gotten it if you, instead of shitting on Faris in the applied stats group, you paid attention. So this is both. Anyway, norm inverse. Yeah. Now we are ready to solve the z-test question in the quiz. Go to the quiz right here. How do you know whether to use z-test or t-test? If the standard deviation is not given, it's t-test. If it's given, it's z-test. Right. So we start another attempt. Okay, so you see here, standard deviation is given, which automatically means it's a z-test. Now z-test, the first thing that we do, we collect our data, copy this. Whether you guys can see Microsoft Edge, right? You should be able to see the browser. Can someone confirm in the chat? Oh yeah, and you scared me for a second. Like I see a MATLAB, I thought it was MATLAB. Okay. So just so one more thing, you said MATLAB. This is an important difference. This is Octave. The thing that's running right now is Octave. So some of the syntax is different. Yeah, just in case. Because if you try something that works on MATLAB and it doesn't here, you will, just automatically realize that it's a syntax difference. So the first thing we do, we collect the data, right? We got data is equal to, boom. Now you have all the data in a vector. Okay, what's next? The mean value of soft drink in bottles is 750 ml. Use a 97% confidence level. So what I normally do is just Control C. Just copy the whole thing here. Okay, so what did you say? 750 ml is the mean. Okay, so mean is equal to 750. Confidence is 97%. So remember in z-test and t-test, you don't need the confidence level, you need alpha. So alpha is equal to um, 1 minus 0.97. Okay, standard deviation is equal to 6. And with that, we can just delete this line. Now we have the information needed. Now, just yeah, thanks for the help, Omar. I'm just doing it like how I would do in an exam because you're limited on time. This is how you do it the fastest way. So then, just in case you mess up, just do help z-test. Unless you're literally Sadman, you should always do help z-test. It says, okay, z-test expects xm sigma or xm sigma name value. We'll be doing this name value. So one more thing we have to do here. See, the mean value is 750 ml. And it says here it's either m is equal to this or not equal to this, which means both tails. This is also important. So we do the first we write the parameters, which is h, p, the confidence interval, and the z value. By the way, these are just variable names. You can literally name it anything. You can name it like it would work. You know what? I'll do it. Why not? So z-test. What do you expect in the z-test? You expect the data, all right? Pass in the data. Oh yeah, it's technically Doraemon, but my whole childhood I used to search Doraemon on YouTube, and I was a pretty dumb kid, but this is this is a hill I'll die on. So the data and the mean, what is the mean? We've already stored the mean. You just make it bigger. Mean. And then the names and the values. The first one will pass in the alpha. Then we are giving the tails. So it's tail and both because you saw it. Now check. Invalid value for standard deviation. Oh yeah, I didn't give standard deviation. See, xm sigma, I forgot the sigma. So STD. Okay, so the value of h is 1, which means let's see here. He tells us that okay, 0 if the null hypothesis is accepted, 1 if it's rejected. So in this case, the null hypothesis has been sadly rejected. So that's h. P is the probability value, it might be asked. Ci is the confidence interval. Doraemon is -4. Now, I just wanted to show you it's just a variable name. We normally write z there. So the output value of the z-test. Now you can just erase help so it doesn't take up all the space. User is asking, do you mind if you could explain again for when we have to use left tail, right tail, or both? If it is less than, then left tail. If it is more than, then right tail. If it is like this, where it says it's either equal to or not equal to, then we use both tails. So in this case, we are using both. Okay, so we're done with the z-test. Then the only other thing we have to do is the critical value. You remember norm inverse. And I will do help norm to just to check which parameters I have to put in octave. It expects P and yeah. Okay, octave sucks for this. Okay, it just expects the alpha value. So since this is both tails, for the z-test. Since this is both tails, we will pass in alpha divided by 2 and 1 minus alpha divided by 2. Okay. Now we have these values. Now we start submitting. H is 1. We go here. H is 1. Okay, H is the decision, by the way. H is the decision. H stands for hypothesis. So the decision is 1. Okay, what else? The critical values. So one thing is the so one sign that you did everything correctly, like you copied the you copied the data exactly or correctly, is that these critical values will be the same but with the sign difference. So okay, now you put in the critical values. The boundaries of the region of acceptance critical value, lower critical value, the upper critical value, which is the same but with a plus. What is the value of the test statistic? This is the Doraemon or the Z value, the last one. Here is Z. You copy that. Is that. Now here, either M is equal to the null hypothesis. What is the null hypothesis? M is equal to 750. So you literally just have to write 750 from here. He does this to make sure you're paying attention to the question. Okay, or M is not equal to 750. That's it. So that's filled in. I'm going to now finish the attempt. Submit all. It should be correct. Yep, it is completely correct. That is the z-test. Now, if you know how to do the z-test, you know how to do the t-test. It's literally the same. If you want to see the code, it's here. But all of the code is also on the Telegram. Here, the Telegram group. Ahmed asking how to know when to use z-test. Yes, like I said earlier, see, these are the questions you can get. If the standard deviation is given, it means z-test. If the standard deviation like this is a t-test question, no standard deviation is given, which means it is t-test. That's how you'll know. So with that, we move on to the t-test, which is the exact same as the z-test, but only a tiny bit difference. Okay, so what is the difference between the z-test and the t-test? If you see here, ugly graph. So if you see here, if the standard deviation is given, we go for the z-test. If it is not given, we go for the t-test. And the critical value function for z-test is normal inverted. For t-test, it's t invert. That's it. And there is just one more thing in the t-test. When finding the critical values of a t-test, we are asked for something called degrees of freedom. What is the degrees of freedom? Let me also go. Yeah. What are the degrees of freedom? Degrees of freedom is basically the number of data points minus 1 for z-test and t-test. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. What is the degrees of freedom? 9. So I'll erase this. Now we start with the t-test. Since it's very similar to the z-test, I'm just going to start solving it and you'll see. First we put in the data. Data is equal to 60.2, 4, 58.8, 63.6. Okay, that's the data. Okay. Now we have the data from here. It is known that an established variety of tomato would have a mean yield of 60 kg. There we go, we have our mean 60. Confidence interval is 95%, which means alpha is 1 minus 0.95. And here, whether the new variety has a different mean yield, which means different means we are using both tails, stating clearly a null and alternative hypothesis. Okay, so we have this information for, you might have noticed that STD is not given. There's no standard deviation now. So what that means is t-test. So the t-test. But first, just do like a help. What does t-test say? X, Y, parameter. Yeah, here, XM. Okay, XM, parameter 1, parameter 2, parameter 3. So literally the only thing that's given to us is the data and the mean, no standard deviation. And sigma is not given. So we do t-test, data, mean, and then we give the alpha, and then we give tail, both. Both tails because it's not equal. And then as for the parameters, put them in the bracket. And the parameters will be similar to the z-test. The first one is h, the hypothesis, p, the probability, ci, the confidence intervals. And the last one, instead of z, we'll just call it t because it's a t-test. And this should be the values from the t-test. H1, which means it's rejected, like our null hypothesis, the probability, the confidence intervals, and the t, the result of the test. Now in the z-test, you just got one value. In t-test, you get multiple values. So what are these? T-stat is basically the z-value, like it's like the z-value, it's the result of the t-test. df is the degrees of freedom. What? What do you mean CI isn't in t-test? I mean, it's not relevant, but it is in the t-test. I have it in Sadman's notes. But you are right that it's irrelevant. But it's just there for the sake of remembering. For z-test and t-test, they have four H, P, C, I, and Z, and then H, P, C, I, and T. No, if H, P, C, I, and T will work for the t-test as well. I got it confirmed from Sadman. But yeah, okay, so these are the results. So what t-stat is the result of t the t-test. df is the degrees of freedom. So the degrees of freedom, I told you what they are. You can just get them through this. Now for the critical value, finding the critical value for the t-test is the same way as the z-test with one extra parameter. So you do critical values is equal to, you use, instead of norm INV, you do TINV. And the values, the alpha, you give it the same way. If it's both tails, you have to give alpha divided by 2 and 1 minus. Yeah, it's a chi-square test that has three values. Okay. So yeah, we pass in the alpha just like that. And the second value is the degrees of freedom, which is 9, 9. So now you can run it and you have the answers. And here you can see the professor, however, is only taking two parameters, but ignore this. And now we can go jump right into the question in the quiz. See, standard deviation is given. This is the test. It's not of in our interest right now. Okay, t-test. This is the data. Mean is 50 kgs. Level of confidence 95%. No standard deviation given, which means t-test. Now here one thing is interesting. Here they let us choose the alternative hypothesis. In the z-test, they decided that it was not equal to, which means we used both tails. In this case, they let us decide either we choose not equal to or we choose bigger than or smaller than. And we put the number, like if we put 0 here, it means not equal to, because we can't type the exact not equal to sign here. That's the problem. 1 means bigger than, 2 means smaller than. So if you have this choice in the exam, I recommend you choose 0, which would mean you use both tails. But right now, since I am demonstrating, I will choose 2, which means the alternative hypothesis is only smaller than 50. So, smaller than, we use the left tail. So keep this in mind. Okay, now we have the data. We store the data. Yeah, that's why I said it. I always recommend to put in 0. It's safer to put 0. But right now, since I'm demonstrating, because it is very possible that he will choose it for you. He will say, okay, m is bigger than 50. Then the people in this meeting will fail because they don't know. I didn't give a demonstration of how to do it. Yeah, see if Fuad said he will fail for sure. So yes, 0 is both. 1 is left, 2 is right. But keep in mind, maybe the Professor Chandra will put 2 is only smaller than. So you have to pay attention. Like I heard that he checks whether you pay attention or not. But anyway, I'll just post the TQC. Okay, mean is equal to 50. Alpha is equal to 1 minus 0.95. Now we have all the values already. Now we can go for the t-test. We take the parameters h, p, confidence intervals, t value is equal to t-test. Okay, what do you give for the t-test? You give the data, you give the mean. And just a second. By the way, the shortcut to commenting code is control slash. So I can just comment out a whole line. And I'll do whole. Okay. Name value. And to uncomment, I press control slash again. Okay, so it takes data, mean, and then name value. So alpha, and pass in the alpha parameter. Tail. Now this is interesting. We chose less than 50, which means left tail. So instead of putting both, I put left. And then we'll find the critical values. I'll just do this. So these are the results. So C confidence interval goes minus infinity to 52 because we have chosen left tail. So anyway, degrees of freedom is 4. So critical value is equal to T I N V. The first thing we have to give. Okay, this is another thing. Based on the tail, you give the value of alpha. So left tail means there is always a 1 on the right. The left tail would just mean there's alpha and 1. And what is the other value that you give to TINV, which is the degrees of freedom, which is right here. It's 7. So you put in 7. And now you can start solving. No, you can start putting in. Okay. Boundaries of the region of acceptance. So you can even tell by, you can even tell by the question that infinity is expected there. But why isn't it accepting infinity? Is there a sign for infinity? Yeah, I tried putting capital I. Didn't accept it. Well, let me see if Sadman is awake. Oh yeah, he's awake. Man, he's always on the grind. Hisham, I am not sure of that. The critical value, are you sure? Let me just confirm with. Oh, okay. Sadman said that in e-learning, only both tails is implemented. We tried right and left tails. Those give wrong answers. See, he has tried literally everything. This guy. Okay, so we'll just have to start over. But you know how to do right tail and left tail, just in case. Well, stop being a philosopher. It's just the way it is. That means we need to use 0 only. Okay, Sadman said that right now it's not implemented. We can only choose 0. But now you guys know how to do it, just in case they surprise you. So I'll just start over. So 0. Uh, no, this is not in my notes that this doesn't work on e-learning. But the solutions, yeah, they're in my notes. Okay, so what do we change now that we are doing both tails? First thing we'll have to do is in the t-test, we use both tails. Second thing, in the critical value, we put in the both tails alpha. So alpha divided by 2 and 1 minus alpha divided by 2. Okay, now the critical values are By the way, Hisham, I think the critical values are minus and plus of the same only when we are using both tails. So these are the critical values. What else is needed? I think H is okay. H is 0, which means the null hypothesis was accepted. The value of the test statistic, that is H. Well, no. In this case, the value of the test statistic is T stat, which is 1.4517. We pass that in and we will finish the attempt and see if it's correct. Yes, sir, we got all correct. Yeah, that's the thing. He can ask you, like, he will twist this question into different ways. And there is a small chance that he might make questions of his own, in which case all of us, including Sadman, will be at the retake. Because what I'm teaching is stuff that Sadman himself is using, and we should write infinity. Then, in that case, you ask the professor in the class. He's pretty helpful. Ask him, how the hell do I write infinity? How the hell do I write infinity here? And he will tell you. They're probably going to use some kind of Unicode solution. But yeah, that solves the t test. And I think I'll actually take a break before doing the next lecture about chapter 9, chi squared. Chi squared isn't going to take that much time compared to the z and t tests. But yeah, any questions about the t test? I'll count. Uh, how big are 10, 11? Hmm. 10, 11 are pretty small, but they're significant. I would say 9, 10, 11 are going to take equal amounts of time. Well, maybe 10 and 11 will take the same amount of time as t-test and z-test. But yeah, if your programming is good, then 10 and 11 will be easier. Also, in the oral exam, you don't have anything to lose. You can go there and you can just do the fortnight default dance and you're not going to lose any score. I think you just have to show up. You only have everything to gain. If you do well, you will get, I think, well, plus however. If you don't do well, you will just get -0. No, I don't know well. I guess impress him with your definition, theoretical knowledge of applied stats. But yeah, this stuff you can ask in the group. I'm going to end this meeting now so the recording can start getting processed. So I'll see you guys in the next one.